Hello everyone and welcome to this experiment 5 in RS2 software, that is comprehensive analysis of materials and staging in underground mining using RS2 software. Here we analyze the data which is already pre-existed in that. Just we analyze the stresses and total displacement, that is horizontally, vertically, and some strength factors and other tools. These are very much useful tools are there to analyze and understand the data. Let's moving on to our model. Then first we have to go for the file. Here you can see recent folders and click on tutorial folders, then scroll down. Here you can identify underground mining and select and click on open. Then click on materials and click on open. Okay, this is already there a model, so just we have to compute and interpret. These two steps we have to done. That is then we have to analyze the remaining parts. Then go for analysis and here you can see compute, then click on compute and click on yes. Then go for analysis again and press on interpret. Okay, you can see a model here. Then select sigma 1. Already selected sigma 1, that is a major principal stress. So just observe the stages here. Stage 1 you can see 40.41 megapascal, and stage 2 17.58, and stage 3 60.85, and in stage 4, that is backfill, that is 60.84. So by from stage 1 to stage 4 there is changing major principal stress. Likewise, just go for the solid effective stress and again select effective sigma 3, that is a minor principal stress, and just have a look the minor principal stress, that is sigma 3 21.86 here in stage 1, and stage 2 22.53, and stage 3 20.5. It is gradually increasing the confining stresses and backfill. This is the minor principal stress in stage 1 and stage 2 and remaining stages. So I want to show one tool here to analyze at a time the 2-3 stages here. So by that way we can understand and analyze the data here. So for that click on here, you can see window. So click on window, then click on new contour window again. So we need 1 or 2 tabs extra. That's why then we can easily analyze the model. Okay, let's again click on window. So here you can see tile horizontally and tile vertically. If you click on tile horizontally, there is a there is a 3 tabs are there, but we are unable to identify clearly that data. So then we go for the vertical. It show clearly the tile vertically. Okay, so here you can see here you can see 3 tabs are open vertically. Then we can analyze data by selecting stage in different tabs. Okay, in stage 1 in first tab, and stage 2 and in second tab, and stage 3 in stage 3 in third tab. By that way we can analyze the data, that may be the principal stresses or the strength factors. If you want to move the excavation, then pan, click on pan and move like that. Okay. Likewise, we can analyze at a time in 3 stages. That is the main advantage of this tool. That is a tile vertically. In horizontally, we are unable to understand the data or unable to see entire data. If we, so that's why these tile vertical is very much beneficial for us. So this is about this tool. So let's moving on to the topic. Let's zoom in. Then I want to pan. Okay. Analyze separately. Done. So we have to go for the stress trajectories. So we have to apply stress trajectory. To apply stress trajectories, we have to go views, and you can see here one display options. Then click on display options. Then there are deformations trajectories. Here the first tab, first tab is stress trajectories. They click on stress trajectory, then apply, then done. These are the stress trajectories. So first and foremost, what is stress trajectories? That is very important. Simply I will tell you the stress trajectory. Stress trajectory is nothing but which gives the direction of the principal stresses. There is one definition is there to remember. What is the stress trajectories? I will tell you that. A stress trajectory is a curve within a material that follows the direction of a principal stress. Simply we can call as direction of the principal stresses. So that is a definition, and you have to know the what is the use and what is it. Generally in 2D stress field, there are two families of stress trajectories. They are very perpendicular to each other. Let's see here. These are the perpendicular to each other, then sigma 1 and sigma 3, like that. And simply I will tell the what are the uses of the stress trajectories. Generally, which is used for the identification of stress distribution, prediction of crack formation, and determine optimal placement of reinforcement of structures and some other geological formations. These are the uses of the stress trajectories. Okay. We are I think you are very aware of the stress trajectories. Let's moving on to next thing, that is strength factors. Okay, strength factors. Let's select strength factors here. This first of all we have to remove these stress trajectories which makes so much complicated in diagram. So I want to remove it. Stress trajectories. Then sigma 1 I have to change into stress factor, strength factors. That is these are the strength factors. You can see here from the red color to blue color, which shows the strength factors from increasing from top to bottom. So I want to know the strength factors from stage to stage. We already know the tool which analyze simply. Then click on new contour windows 2 times. It gives 3 stages here. Then select in stage 1 in first step, and stage 2 in second, and stage 3 in third. Then analyze, then select here, then okay, identify, then zoom in. Here you can see the strength factors. So select strength factors here, sigma 1, sigma 1, sigma. It's showing sigma 1 in another thing. Then select here, first of all select this second tab and change into strength factors. Then select first tab and select into strength as a strength factor. Okay, these are all the strength factors. Select this third one. Okay, here these are the strength factors. you can see in stage 1 and stage 2 and stage 3 and first stage 4. Okay, by that way we can analyze the strength factors at a time in 3 stages. That is this is for another step. Then identify then go for next step, that is go for view and click on display options. Here I want to add nodes and elements. First and foremost, you have to know what is node, what is element, and yeah, I think you're already aware of that, but I will tell you some in briefly what is node, element, and mesh. Generally, the mesh, we apply mesh to the model, the model which disintegrate the whole body into some grids. Okay, that grids, but each grid is nothing but element. Okay, that is element. That elements are connected, one element is connected to another by the nodes. That connection is nothing but node. So here you can see these are the nodes. Okay, I will remove the tab and I will select only one tab. It gives clear information. Okay, directly we can right click here and display option is there, then directly you can apply the nodes here. These are all are the nodes. Then this is element, numbers, and mesh. Okay, I will explain clearly here because simple. This is I applied mesh. These are the all are the this triangle is that is element. This connection is nothing but node. So mesh disintegrate the whole body into elements, and these elements are connected to one to another through one connection. That connection is nothing but node. So I want to give some extra information on nodes, that is loads and constants and other boundary conditions are applied only for the nodes but not for the elements. That is important. Just that loads or another thing information is added for the only here nodes. So here you can see elements, these are the numbers, elements. I selected only element numbers. Okay, you showing element, this is the 66 element, this is 77 element, this is 78 element. Then apply node number. This node number, it is much complicated. So this is the 842 node. This is this connection. So I think you are aware of it clearly. What you know what is node and what is element and what is mesh. Okay, so then remove these are all things. Then you learn what is node, what is element, and what is mesh. Okay, then moving on to the another one, that is displacement. This we have studied strength factors, and then go for the solid displacement. Here select total displacement here. Okay, total displacement, then pan, so better. Let's use our tool, that is new contour window. Click 2 times, then it gives 3 tabs, then click on tile vertically. Okay, we are aware of it. Then drag it, identify. This is about then select in first tab, that is stage 1, and second stage 2, and third stage 3. Then zoom in, drag it and zoom in. These are the displacements. Here you can see 3 tabs, but in one tab it's showing only total displacement, and in another two tabs it is showing only sigma 1, so we have to change to solid displacements and click on total displacement. Okay, then select the first tab and then go for solid displacement and select total displacement. Okay, here you can see the displacements here from blue color to red, top to bottom displacement is increasing. Okay, here, so just you want to show only the model, then remove legends. Okay, remove, then click on the these legend option, then hide legends. Same as you have to click on the right click on it and hide legends. Then now zoom in, you can see the variation of displacement, stress, everything here. So in stage 1, stage 2, stage 3, and if you want to move, then pan it. Okay, this is stage 1, this is stage 2, and this is stage 3 here. Shown clearly. This is about displacements. Then remove the span, and if you want to contour this automatically. And next step is I want to study deformation boundaries here. Deformation boundary. This is the boundary now. This is the tunnel excavation. This stage 1, stage 2. There are 3 stages of excavations are there. Here you can see this is the boundary. So we have to study the boundary deformations towards the opening. How the deformation is causing or occurring towards the opening. Let's study the boundary deformations. How we can study? Just right click on here and go for the display options. Here you can see deformation boundaries, then click on deformation boundaries, it show this is a deformation, but need a clear deformation, then